Hello students and those who are interested in mathematics. This is solved problems that are related to grade 12 Mathematics Ethiopian University entrance examination in English, which is part 5. In part 4 we try to solve some of the problems, and now today we will see questions, the remaining questions, which is related to again University entrance examination. Let us begin with this one. This is question number 17. It is about geometric series. Actually, we will check whether this series is geometric or otherwise. Let us begin with to solve this particular example. Now let me choose my marker here. The sum of the question says the sum of a series, the summation of n running from 1 up to infinity, n is from 1 up to infinity, in bracket 2 to the power of 2n plus 1 over 5 to the power of n minus 1 is equal to, that is what the question says. Here there are answers here in this choice. Now we need to select one of these numbers, which is equal to this particular summation or this particular series. Here is, let us begin. The summation of the question says the summation of n running from 1 up to infinity. Here let us observe the expression in the bracket. By the rule of exponent, we know that a the power of m plus n is equal to a the power of m times a the power of n. That is what we know from the rule of exponent. Here a the power of n. This can split in two. And moreover again, if there are a the power of m, something like this one, if there is something like this one, a the power of m over again b the power of m. Now observe that the exponents are the same. The exponents of the two bases are the same. Here a over b are different. Here the bases are the same. Then we can split this into two, but in here we can merge both in one exponent. As such, here a over b, by the rule of exponent, this becomes a over b the power of m. That is the rule of exponent, actually the power of m. Once you know these rules, then you can arrange this expression so that we can find the kind of sequence, what kind of sequence it is. The first thing we have to do is just in the bracket here, the expression in the numerator, which is 2 to the power of 2n plus 1, can be split by using this property of exponent as 2n times, we can make like this one, 2 to the power of 1. We can split into 2 as a product of two exponents. And moreover again, the expression indicated in the denominator of the expression in the bracket can be rewritten as 5 to the power of n times 5 to the power of minus 1. We can write like this one, 5 to the power of minus 1. Now observe that these are numbers which are independent of n, but these are dependent upon n. Therefore, we can take it out, these numbers which are independent of n, even from the summation, the sigma notation. But let us rewrite this one as such. Let us rewrite this as such. Here it can be written as, take out from the bracket 2 over 5 to the power of minus n, minus 1 I mean. But in the bracket, this is minus 1, but in the bracket leave this one. To the power of 2n can also be written as, let us see the rules of exponent. If there is a number base which is greater than 1, different from greater than 0 but different from 1, if the exponent of this number is written as a the power of m times n, then we can rewrite this one as a the power of m in bracket the power of n. This is the rule of exponent. And likewise, to the power of 2n means to the power of 2, which is 4 the power of n. It becomes like this one, 4 the power of n. We can write as 4 the power of n. And again, in the expression in the denominator is only here 5 the power of n. 5 the power of n. Close the bracket. That's it. Now, as you can see, this is going to be a geometric series, because anything which can be written as exponent as such is said to be a geometric sequence. And therefore here 5 the power of minus 1, again let us see another rule. A the power of minus 1 is always equal to, by the rule of exponent, it becomes 1 over a, provided that a is greater than 0 and a is different from 1. And therefore this thing becomes 5 the power of minus 1 means it is 1 over 5. And then if 2 is divided by 1 over 5, this expression is going to be 10. 2 divided by 1 over 5 gives us 10. Here our n is running from 1 up to infinity. 1 up to infinity. Now let us check whether this series converges or diverges. And this series becomes, let us write somewhere here, the summation of n running from 1 up to infinity, sorry, the infinity is not actually like that one, unless and otherwise we assume it is infinity. Now this is we say this is 10 and 10, and write the expression, the exponent in bracket, as one exponent, which is 4 over 5. 4 over 5 the power of, this is 4 over 5 the power of n, the power of n. Observe here, always if a sequence is written in the form a over n, we say a as the power of n, we say it is a geometric series, and the common ratio in that case is a is a common ratio. And therefore, without any doubt, we know that when our n is equal to 1, our g1, the common term of this geometric sequence, is going to be 10 times 4 over 5 the power of 1, means it is 4 over 5. 4 over 5. 4 over 5. 5 when 10 is divided by 5, this is by 5 1, by 5 10 is 2. 2 times 4, it gives us 8. It gives us 8. And directly we take the common ratio r from the expression in bracket, which is exactly equal to the expression in the bracket, which is 4 over 5. Now observe again, 4 over 5 is a number which is between 0 and 1. Between 0 and 1. We say in geometric series, in an infinite geometric series, if the common ratio is between -1 and 1, then the geometric series converges. And therefore, this is equal to, if it converges again, if it converges, the sum of the series will be the sum s or up to s of infinity. If the geometric series converges, then s infinity is equal to g1 over 1 minus r. That is what we have already derived in the previous lesson, and therefore here put it like this one. Our g1 is 8. Write 8 here. 8 over 1 minus r, which is our r in this case is 4 over 5. It is 4 over 5. By calculating this one, by performing this operation here, as you know, write 8. The denominator is 8. If you don't mind, it is helpful if I clean this place in order to not mess up here. Let us clean here. Clean, and it is cleaned. And then write 8 here. 8 over 1 minus 4 over 5 can be equal to multiply 5 by 1, which is 5. 5 subtract 4 from 5, and then we have 1 over 5. 1 over 5. If 8 is divided by 1 over 5, the result is equal to, directly multiply 5 by 8, because division can be changed into multiplication by taking the reciprocal of the second term, which is going to be 40. 4o. This is because 8 divided by, we say, let me show you here, 8 divided by, this means 8 over 1 over 5 means 8 is divided by 1 over 5. That is the interpretation of that fraction. And this can also be changed into multiplication by taking the reciprocal of the second term, which is 8 times, take the reciprocal of this one, 5 over 1, it becomes 5 over 1, but no need to write 1 because everything over 1 is itself, and therefore 8 times 5 gives us 40. That is the solution for question number 17. Now let us see the one I already done using the computer. Here the summation, you can finish it in one line, on one line. Here the summation of n running from 1 up to infinity to the power of 2n plus 1 over 5 to the power of n minus 1 is equal to the summation of n running from 1 up to infinity 2 times, we can split this one into 2, and then it becomes, finally it becomes like this one. Therefore the answer is, A is going to be the answer. Now let us see the next question. We are about to complete chapter 1 of grade 12 mathematics, and the next chapter deals with calculus, which is calculus, derivative, and the differential calculus and the integral calculus. We will see that later on after we complete the application of sequence in the series in this part. Now let us also see this question. Question number 18 says, what is the sum of the series? The summation of n running from 0 up to infinity to the power of n times 3 to the power of 2 minus n. Now the problem lies with this one. Can this sequence, this is a general term of a certain sequence, can this general term be geometric or arithmetic? Let us identify whether it is arithmetic or geometric. The first thing we have to do is write the summation of our n is running from just 0, from 0 up to infinity. This is an infinite series, and the expression in bracket can be split into as the following. Let us see. 2n times multiplied by 3 the power of 2 minus n can split into 2. It becomes 3 the power of 2 times 3 the power of minus 1 using the rules of exponent. And the 3 the power of 2 is a pure number. It becomes 9. It is independent of n, and therefore we can take it out of the sigma notation, or we can leave it somewhere here. And this becomes the summation of n running from 0 up to infinity. Our n is running from 0 up to infinity. Since we say this is 9, 3 the power of 2 is 9. Write 9 somewhere here. And the times, we have 2 the power of n times 3 the power of minus n. But remember, a the power of minus n can be written as a positive exponent as 1 over, if we take the reciprocal here, this is actually not a reciprocal. Now we can write as changing the negative exponent into positive exponent can be given as this. This is a rule, one of the rule of the exponent. And similarly, we can take this one, we can change this negative exponent into positive exponent as such. 2 the power of n times 3 the power of n can be rewritten as 3 the power of n. 3 the power of minus n can be rewritten as such. And moreover, again, here we have 2 the power of n as a denominator, as a numerator, and 3 the power of n as a denominator, and therefore we can take the base, we can take one of the exponent with the base 2 over 3. And here we have the summation of our n is running from 0 up to infinity, into 9 in one bracket, in one base. We can write like this one, 2 over 3 the power of n, take one of n only, combine the two. Now here, to find the first term, let us call it actually G0. It becomes G0, whatever it is. Let us call this one be G1. Here, where our n is equal to 0, then we have 9 times 2 over 3 the power of 0 means it is 1. 9 times 1 gives us 9. That is our G1. But we say the expression, the number in bracket with the exponent here is directly equal to the common ratio of this is the geometric series. This is actually geometric series since it is written in exponent form. We already discussed about this one, and therefore our common ratio is going to be 2 over 3. Here 2 over 3, we again, let me repeat it. A geometric series can either diverges or converges depending upon the common ratio. If the common ratio is 1, it diverges. If the common ratio is greater than 1, it diverges. If the common ratio is less than minus 1, it vibrates. It vibrates and it diverges actually. And if the common ratio is in between minus 1 and the 1, it converges. That is the common rule of actually geometric series. We already proved this one. And here, this sum in that case, since it is a geometric series, which converges, we have this sum, which is equal to 1 minus the common ratio r. We have both variables. G1 is 9 and our r is 2 over 3. Then 9 over minus 2 over 3, 2 over 3, multiply 3 by 1. To perform this operation, multiply 3 by 1, 3 times 1, it is 3, 3 minus 2, it is 1, and therefore the whole result becomes 9 over 1 over 3. 1 over 3. It becomes 9 over 1 over 3, which means divide 9 by 1 over 3. We have already seen, we have already observed what this will be. When 9 is divided by 1 over 3, then directly multiply 3 by 9, and the result is going to be 27. That is 27. And therefore, this series, this infinite geometric series, converges to 27. We got the answer, and the answer in this case is, therefore, it is C. Now here you can finish it in one line. We can actually finish it in one line. If you practice the rule of exponent, then you can solve, you can find the summation, the infinite geometric series as such in one line. This is question number 18. The next question, it says, actually this is also similar. I repeat once again, this kind of geometric series always for the past 10 years appears on the Ethiopian entrance examination, university entrance examination. Always one which is either similar to this one, or which is again itself can appear. This was actually taken from the entrance examination of I don't remember actually. It is it is from 2000 I think 2017 or something like that. Now let us deal with this one. Here is what the question says. Which one of the following is equal to the sum of the series here? The summation of k running from 1 up to infinity into 4 to the power of 3 minus k, and we can write like this one. We can solve this problem as such. Here our k is running from 1 up to infinity, and also the expression into in the bracket can be split. This exponent can split as 4 to the power of 3 times 4 to the power of k, 4 to the power of minus k, 4 to the power of minus k. We can split as such. 4 to the power of 3 means it is 64. Therefore, the summation becomes like this one. The summation k running from 1 up to infinity, and that assumes that is infinity. Here we have 64. The expression in bracket 4 to the power of minus k means it can be written as, this is 64, it can be written as 1 over 4 the power of k, because 4 to the power of minus 1 means it is 1 over 4, and therefore the whole concept, the whole idea of this one gives us 1 over 4 to the power of k. Now, what is G1? We know that this series with the general term 1 over 4 to the power of k is a geometric sequence. This sequence is a geometric sequence, and the series is called the geometric series. And therefore, when k is equal to 1, then the first term is going to be 64 times 1 over 4. It is 1 over 4 here, because 1 over 4, the power of 1 is 1 over 4 itself. And moreover, when 64 is divided by 4, it gives us 16, 1 6, 16, 1 6. Therefore, the first term of this series is 16, and automatically we know that the common ratio is 1 over 4, 1 over 4. Then apply the sum of geometric, the geometric sequence as n goes to infinity, which becomes, and r, if r is between -1 and 1, that thing becomes g1 over 1 minus r, g1 over 1 minus r. And since this is true, if our r is between -1 and 1, and therefore here our r is equal to 1 over 4 is always between -1 and 1, and then everything is given. We obtain already g1, which is 16, and we have also the common ratio r, and perform this operation. Here, as you can see, 1 minus 1 over 4 means multiply 4 by 1, it becomes 4. 4 minus 1, it is 3, and therefore this is 16 over, this is 3 over 4. 1 minus 1 over 4 is 3 over 4. Then 16 divided by 3 over 4 can be, now the division, it can be changed into multiplication by taking the reciprocal of this one. Then if we take the reciprocal of this one, it becomes 4 over 3. Then multiply directly 4 by 16, which is 64. It returned back to the original 64 here. 64, leave 3 where it is. It is 64 over 3. That is our answer. That is the number to which this infinite geometric series converges, because the geometric series is the series is geometric, then it converges, because r is 1 over 4. It is between 0 and 1. Our answer is therefore B. B is the answer. Now the already done solution is like this one. You can finish it immediately. Just save the time during examination. Particularly, you have 3 minutes for each question in mathematics in Ethiopian on Ethiopian University entrance examination, and therefore you can save time for such kind of question. Now let us see the next question. Question number 20. It is now unique from the previous one. From now on, we will say application. Here, question number 20 says, the sequence in branches. This is the general term of we don't know what kind of sequence it is yet. Here, this sequence n minus 1 in bracket times 2n plus 1 over 1 minus n squared. N is running from 1 up to infinity, converges to, it says, converges to where? Let us see. We don't know yet. As n goes to infinity. Where does this sequence converges to? Let us see. Write down first the nth term, which is written in the braces as such. N minus 1 times 2n plus 1. That is the numerator. The numerator is n minus 1 times 2n plus 1. And the denominator is 1 minus n squared. Now this can also be equal to common out n from the first bracket. Common out n. If we common out n, what is left in the bracket? The expression in the bracket, this n is common out, therefore it leaves 1 here. It leaves 1 here. But if n is common out, it leaves here 1 over n. 1 over n. Why is this so? Because if we multiply n by 1, it becomes n itself. If we multiply n by minus 1, n by minus 1 over n, then the result becomes minus n over n. N over n is 1, and again we will get minus 1. And again, similarly, common out n from the next bracket. N into, remember this is multiplication, or these terms are multiplied to one another. It is a product, it is written as a product. Then when n is common out, what is left here? It leaves behind 2. It leaves 2 behind. But here it leaves 1 over n. The scenario is the same. n multiplied by 2, it gives us 2n. n multiplied by 1 over n, it becomes 1, and therefore there is no change. No change. We change nothing. And over again, common out n square from the denominator. If n square is common out from the denominator, it leaves here 1. But here we have 1 over n square. 1 over n square. And 1 over n square minus 1. Because if n square is multiplied by 1 over n square, it becomes 1, which is equal to this one. If n square is multiplied by minus n minus 1, it becomes minus n square. That's it. No change. Since multiplication is again commutative, multiply n by n. Multiply n by n. It gives us n square, n square, n square into 1 minus 1 over n, and again into here, multiplied by, sorry for such kind of bracket, and here the expression in this bracket is also 2 plus 1 over n. 2 plus 1 over n. Remember again, what will happen to 1 over n as n goes to infinity? That is what we are going to discuss. N square into 1 over n square minus 1. Minus 1. Then cancel this one. Let us change the color of my marker. Change this one. Change this one. This cancel this one. And as n goes to infinity, as n becomes bigger and bigger, or larger and larger, then 1 over n goes to 0. 1 over n becomes 0. It goes to 0. It is not 0, but it is nearly 0. And also here 1 over n here goes to 0. And here also 1 over n square goes to 0. Why? Our n is very larger and larger. It goes to infinity, and then when 1 is divided by a very large number, then the result approaches 0, and therefore now what is left in the denominator? Here as a denominator 1, we have 2 here. Multiply 1 by 2, it gives us 1 times 2 gives us 2 as the denominator, And again here, what is left? This is 0, 0 minus 1 is minus 1, minus 1 times 1, it is minus 1. Minus 1. 2 over minus 1 is also equal to minus 2 itself. Minus 2 itself. And therefore, this sequence converges to minus 2. It is a convergent sequence. It converges to minus 2. Now here, as you can observe here, it is the same result that we have already seen. Then as n goes to infinity, this expression goes to minus 2, and therefore the sequence converges to minus 2. And what is our answer then? What is our answer? The right choice is D. D is the right choice. This is the right choice. D is equal to minus 2. This question was also taken from the previous entrance examination. That is it for today. In part 6, we will see application of both geometric sequence and arithmetic sequence with their respective series. We will see more advanced examples such as this one here. Therefore, until then, bye. See you. Thank you for watching. Thank you. Please don't forget to subscribe. If you are interested in this video, please subscribe, share, and like, and even leave your comment, please. I am delighted to see your comments, and tell me what I have to improve regarding the way I am presenting the lesson, and then I can improve based on your comments, and therefore don't forget to leave the comment. Bye bye. See you then.